Hello, class. Let's look at 2.1, rectangular coordinates and graphs. Now, in this section, we're going to be looking at ordered pairs, the rectangular coordinate system, the distance formula, the midpoint formula, and equations in two variables. So first thing we're looking at is ordered pairs. An ordered pair consists of two components written inside parentheses. Now, usually when we deal with ordered pair, we use X, Y. All right. Now we may use some points like P, X, Y, so that means point P of X, Y, whatever else. So when we do this, so you may see it in like P, X, Y. That means X, Y's point P in the coordinates is X, Y. All right. So we're going to look at some of these. So let's look. All right. So the rectangular coordinate system. So you have our horizontal axis being the x-axis. We got our vertical axis being the y-axis. And it's composed up in four different quadrants. That's going what? Counterclockwise. So we have quadrant 1, we have quadrant 2, quadrant 3, then quadrant 4. All right. Now, let's say we have point AB. A comes first, so it's like XY. So it's point XY. So anytime you put the point, you have to put X, then Y. So you need to go from 0, 0 to your horizontal, all right, coordinate point, and then go up or down to your B, all right? So you're going left or right on your X-axis, and you're going up and down on your what? Y-axis. So let's look at this. So if we look at the distance formula, all right, it says using the coordinates of the ordered pairs, we can find the distance between 2 points in a plane. The horizontal side of a triangle has a length, all right? So of the distance of PQ, which that's the horizontal spot, is equal to the absolute value of x2 minus x1. So therefore, we're going to have what? The absolute value of 8 minus negative 4. And you will get absolute value of what? 12, so it'll be equal to 12. Now, this is when we're looking for the horizontal distance. Let's look at the vertical distance. So when we're looking at the vertical distance from the distance of Q to R, we say we have the absolute value of y2 minus minus y1. So therefore we have what? Negative 2 minus 3, and that gives us negative 5, but we got to do the absolute value of negative 5, and it gives us 5. So at first we was doing the horizontal distance. This is the vertical distance. So we're looking at the what? Y's. The first time we were looking at the X's. Now let's say if we want to go from P to R, which is a diagonal. Now we have to use something called the distance formula using the Pythagorean theorem. So it says for the length remaining, we have the distance from P to R is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and you're taking the square root of all that. So therefore, we already did the inside, we already did this prior, so we have 12 squared plus 5 squared, which gives us what? 144 plus 25, and then take the square root of that. It's the square root of 169, and we should get what? 13. Now, your diagonal side should be your longest side. That should be your biggest side, because why? That's your hypotenuse. So just make sure when you're doing this, you understand what you're actually doing. Now, let's look at this. So it just says what? So the distance between the point negative 4, 3 and 8, negative 2 is 13. Or point P, the distance between P and R. So that's the same thing we just looked at. It just talking about just the points themselves. instead of using P and R like I use. All right. Now, suppose that P of x1, y1, and R of x2, y2 are 2 points in a coordinate plane. The distance between P and R is written as the distance d PR, or the distance between P and R. All right? Given with the formula that I gave you, d of PR, or the distance from P to R, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And you will use this in different ways. So let's look at something. Let's find the distance between P and Q. All right? Let's look. Let me use black. Therefore, so if I want to find the distance from P to Q, all right, that will equal the square root of, we will say 3 minus a negative 8 squared plus my negative 2 minus 4 squared. Because if I use this as x1, y1, and x2, y2. All right? Therefore, I'm going to have the square root of what? That's going to be what? 3 plus 8, which is going to give me 11 squared, plus, this is going to be a negative what? 6 squared. Then I have the square root of 121 plus 36. Then when we add that together, we got the square root of what? 157. So keep in mind, when you do these, you make sure you look at what you got. So you want to make sure that your stuff adds up to the way that you need to add up. And make sure that everything goes the way you need it to go. All right? So if you have any questions, make sure you hit me up on Microsoft Teams or you hit me up through email. Because we want to make sure you understand what you're doing. So just take a minute and copy it. So let's look at the next thing. So it says what? Determine whether the points M, negative 2, 5, N, 12, 3, and Q, 10, negative 11, are vertices of a right triangle. Now, you're probably sitting like, how would I figure out that? Now, there's a couple ways you can figure out that. And we're going to go through it. So, first thing we want to do, let's find the distance, all right, from M to N. All right? So that'll be equal to the square root. Then we got parentheses. We got 3. We have 12 minus a negative 2 squared. Then we have what? Plus 3 minus 5 squared. And that equals the square root of, and we're going to get what? 14 squared plus negative 2 squared. So let's look at what we got. So we have the square root of 196 plus 4, which is going to give me the square root of what? 200. Okay. That's my first one. Now, let's find the distance from M to Q. All right. So we got the distance from M to Q. And this is equal to the square root of negative 11 minus negative 2 squared. And I wrote that incorrectly because it would be x terms. So it'll be 10 minus a negative 2 squared plus a negative 11 minus 5. And then we square it. And then this will be equal to what? We will have 12 squared, which is 144. Then we have plus, then we're going to have negative 16 squared, which gives us 256. Then we got the square root of what? 400. Now, and we know the square root of 400 is what? 20. Now, one that we didn't do. Let's do the distance from N to Q. And that's equal to the square root of 10 minus 12 squared plus negative 11 minus 3 squared. So that equals the square root of 2 squared, well, negative 2 squared, which is 4. Then we have plus, then we're going to have negative 14 squared, which is 196. Well, 190. So we have 11 minus that. So we're going to have 196. Yeah. So this is going to equal our square root of 200. Now, the way that you figure this is if this is a right triangle or not. And I'm going to use a different color. I'm going to use blue this time. Now, your two lowest ones, if you square them and add them, they should equal what? Your lowest one, right? I mean, your highest one. So, if I did the square root of 20, it's square root of 200 squared plus the square root of 200 squared is equal to 20 squared. Now, this would just be what? 200 plus 200 is equal to 400. Now, so we got 400 is equal to 400. Then that checks out. That means they are what? Right triangles. Because remember your Pythagorean theorem was what? A squared plus B squared is equal to what? C squared. So just keep that in mind. And then this is what your actual picture looks like after you go through that whole process. Now, collinear points. We can tell if 3 points are collinear, that is, if they lie in a straight line using a similar procedure, just like we did the right triangle. All right. 3 points are collinear if the sum of the distances between the 2 points is equal to the distance of the remaining points. So basically, we're going to take the two lowest points, add them together, and see if we can get the what? The higher point. All right, let's do that. So we're going to go through the same process. We're going to look at the different distances. So therefore, and I'll do this in blue. So the distance between P and Q will equal the square root of 2 minus a negative 1. And I'm going to square that plus negative 4 minus 5 squared, which this is just going to equal the square root. I don't need that long. Which this is just going to equal the square root of 9 plus 81. And then that equals the square root of 90. All right. Now, let's find the distance from P to R. So we have the square root of negative 4 minus a negative 1 squared. Let me fix that. Plus, we have negative 10 minus 5 squared. And this equals the square root. Now we have 4 minus 1, which gives me what? 4 minus negative 1, which gives me 5. So 5 squared is 25. Then we have plus 15 squared is 225. So when we equal these, this is equal to the square root of 2 what? 50. All right. And we'll work that, and we'll simplify that momentarily. Now we're going to look at the distance from what? Q to R. Which this would be what? 4 minus 2 squared plus, then we have what? Negative 10 minus negative 4, and we're going to square that. So this right here is basically what? We got 2 squared, which is what? 4. Then we have plus, then we will have negative 10 plus 4, which is going to be negative 6, so it's going to give me negative what? 30 is going to give me negative what? 6, so I'm going to get negative 6 squared is going to be 36. Therefore, I'm going to get the square root of 40. Now, we know the biggest one up here is the square root of 250. So what I'm going to do, go to hit this, and then in red, this is equal to, and we're going to see what this is equal to. Now, what I mean by what this is equal to, I'm going to reduce it. So a perfect square that goes into 90, which is the square root of what? 9 times 10. Which that equals what? 3 times the square root of 10. Perfect square that goes into 40 is the square root of 4 times 10, which that equals 2 times the square root of 10. And perfect square that goes into 250 is the square root of 25 times 10, which that equals what? 5 times the square root of 10. Now, if these two, this one and this one, add to be that, then they are collinear. So we have 2 square root of 10 plus 3 square root of 10, which we see that it equals what? 5 square root of 10. So that checks out. All right? So just keep that in mind. So that works out. So they are collinear because we get them, the 2 other distances equal the third distance. So we're looking at the midpoint formula. It says the coordinates of the midpoint M of a segment with endpoints PX1 and YX, point P, X1, Y1, and Q, X2, Y2 are given by the following. So the midpoint is equal to x1 plus x2 over 2, so taking half. Y1 plus y2 over 2, so it is all over 2. So you're taking half of both additions. So it says find the midpoint that lie with the two endpoints, 8, -4, and -6, 1. Therefore, we're going to say we got what? So M is equal to, we're going to have 8 plus a -6 all over 2. Then we have what? -4 plus 1 over 2. Therefore, we're going to have, we add those, it's going to be 2 over 2, so that'll just be 1, and then we'll get -3 over 2 for the midpoint. Because all we did is use the formula that we previously had. So let's look at this. Now, this one may be a little bit more different because they give you one endpoint and one midpoint. Therefore, if I was working this out, the first one, it'd be what? X plus a -6 all over 2 is equal to my midpoint of 8. Then I got Y plus 12 all over 2 is equal to my midpoint of -2. So I will multiply both sides by 2. So it'll be X minus 6 is equal to, and that'll be what? 16. So X is equal to 22, because I add the 6 over there. Now I'm going to multiply the 2 onto that side, so it'll be Y plus 12 is equal to -4. Then I'm going to subtract that, so Y is just equal to -16. So my X coordinate or my endpoint will be 22, -16. So that will be my other endpoint, will be endpoint Q. Now, make sure if you have any questions about this, you make sure you ask me through Microsoft Teams, or if you have any problems with it, just let me know. So when we're thinking about graphing an equation, so this is Y is equal to 4x minus 1. So my first thing is to see what we have. Now, I like to make a XY table. All right? So I'll put -2, -1, 0, 1, and 2. All right? So when you plug these in, you're plugging in X values. So you got Y is equal to 4 times -2 minus 1. So Y is equal to what? -8 minus 1, which is equal to -9. All right? Same thing with the 1. So Y is equal to 4 times -1 minus 1. So it's equal to what? -4 minus 1. So Y is equal to -5. Then when you put 0 in there, so Y is equal to 4 times 0 minus 1. So Y is just equal to -1. And then when we put 1 in there, so Y, I'll just put it right here. So if we got Y is equal to 2 times 1, well, 4 times 1, sorry, minus 1. It's going to be Y is equal to 4 minus 1, which is equal to what? 3. Then we're going to have Y is equal to 4 times 2 minus 1. And that'll be what? 8 minus 1, which is Y is equal to 7. All right. So therefore, if we wanted to graph this, it's not the best graph in the world, but we're going to get the gist of what we're actually doing. So this is your X, and this is your Y. So my first one is 2 and 9. negative 2 and negative 9. So I need to keep going down this way. So negative 2, negative 9, I know my 2 is here. And let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be around about here. All right. Then we got negative 1 and 5. So we got 1, 2, 3, 4, 5. All right. Then we said we go through the point of 0, negative 1. That's my x-intercept. All right. Then we have what? 1, 3, which is here. And then we have 2, 7. And 1, 2, 3, 4, 5, 6, 7, which is up here. And then we draw our... Now, I did a dotted line just to get the line straight. And then I can go back and fill it in. Not the straightest line, but you get the point. And that's basically how you create and graph a linear equation. And that's how you graph this equation. So make sure if you have any questions about this, you please contact me about it. I want to make sure you understand how to graph these things.